WeatherBELL Analytics, meteorologist Joe Bastardi, your Saturday summary. Well, I got to tell you something. I knew it was going to happen, and it is happening just before the hurricane season starts. A lot of articles coming out. And I wrote a couple articles last year and was very public about them, literally trying to set a trap for the blame game that goes on in the climate agenda. And I explained what led to Harvey's excessive rains, and did this right after the storm hit, and then also pointed out that sometimes in the weather things are just a matter of luck, and I'm going to show you this, or not luck. Show you this a little bit later. But look, this is Tropical Storm Amelia, which came in over here, and then the remnants progressed up here, dumped over 30 inches of rain in parts of Texas, and 48 inches of rain at Medina, Texas, which is located right here. Now, this is in June of 1978, and in a shorter period of time with the storm moving through, dumped 4 feet of rain. Remember, Harvey stalled. So my point is, how did a minimal tropical storm that, there was argument about whether they should have even upgraded it to a tropical storm, though at the time I believe that was a good idea. It had wind gusts of 55, 60 miles an hour, Corpus Christi. How the heck did that dump all that rain, right? Now, its record of 48 inches was beaten by Harvey in this area. And remember what happened with Harvey, though. Harvey stalled. Now, Harvey didn't stall because of some big blocking subtropical ridge to the north. Quite the contrary, and we saw this well in advance. And I made mention of this on August 21st while everyone was staring at the eclipse. We were putting out a lot of things to our clients in Texas, telling them to look out. Look out, this was going to be a real bad situation. Phase 2 of the Madden-Julian oscillation was being forecast, a minimal phase 2, but phase 2 nonetheless, said that it's cold in this part of the country. Well, if you have a tropical cyclone coming up here, that's interesting. Phase 2 is also a high impact for tropical cyclones. I'll tell you why. When it gets cold like this in the summertime, there's usually trouble very, very close to the United States. Why? Because these waters are always warm, and this amount of cold air focuses convergence. So whenever you get that phase 2 of the MJO, there's a lot of convergence right near the coast, the air coming together. And when air comes together over tropical waters, look out. So that's what the temperatures look like during Harvey. The 500 millibar pattern, Harvey interacted with the tail of this trough to stall the storm. If there was the normal strong, or a stronger than normal, even normal subtropical ridge in there, Harvey would have kept moving through. Those rain bands would have never stalled over Houston the way they did. And in addition, you wouldn't have the kind of condensation processes that occur when a cold trough starts a storm. Back in 1963, same thing happened here. October 63, 100 inches of rain in 4 days at Santiago de Cuba actually had Castro blaming the United States for blocking a storm trying to destroy his country after the Bay of Pigs situation the year before. There's actually some weather history in that. Now, when we look also at Harvey's path, if it had been 50 miles south and here, and we had a normal ridge to the north, guess what? It would have never been picked up. It may have been a pretty good storm, but would have stayed to the south. Because of that cold trough to the north picking it up, guess what happened? It turned off to the north. In addition, again, let me point out what this phase 2 of the Madden-Julian oscillation looks like over here. It favors storms near the coast of the United States. And that's something that a lot of people don't understand, that the setup with this cyclone was always there in the first place. When you look at the correlations of the Madden-Julian oscillation and what phase 2 gives, phase 2 is an enhanced phase next to North America. So whenever we're going into phase 2, and by the way, we're going into it now, and that's why I'm a bit concerned about the northeastern Gulf of Mexico next week. Whenever we go into phase 2, forecasters should be on the edge of their seats, and certainly we were. So what's happening now is, well, the water was warmer than normal. It was. That definitely contributed to it. Not saying it didn't. But the point is, if the cold trough wasn't there, you wouldn't have had the stalling of the storm. And even though we could argue about, well, whether it would have rained 25 inches or 35 inches, from whether that was because of the warm water, it would not have stalled and left those repeating bands there. In addition, the cooling of the storm enhances the condensation processes. So without that cold trough in there, which is opposite of the whole theory that subtropical ridges are going to be stronger with these storms to the north of them, make them move slower. That's not what's going on here. All right, this was not the case to use to buttress that argument. It was like in the year before, 2016, they were trying to say Hermine, which took 11 days to cross the ocean and then become a storm in the Northeast Gulf at the height of the hurricane season, Hermine was a sign of climate change. I'm like, how can that be? It's a minimal hurricane hitting Florida at the height of the hurricane season. You see, you got to know which storms to use. Now, there's storms I've seen. I said, well, that's pretty wild. It did this or did that. But then again, we have observation techniques we didn't. So I am laying out in front of you why this storm was no surprise, right? And in addition, like I said, if it had just been a little bit further south, if that ridge was stronger than normal, okay, the big argument is that the subtropical ridge is going to be stronger than normal. If it was even normal, it would have drove the storm in here. Instead, you had phase 2, Madden-Julian oscillation, all sorts of cool here across the United States, stronger than normal, trough tailing down, picks up the storm, and then it gets trapped in here. And when it gets trapped this close to the Gulf, inflow keeps coming in. What do you think is going to happen, right? Okay. Let's get to the upcoming hurricane season. We are tracking very close with the multivariate ENSO index with 2017-18. Now, last year I got fooled to the total ace. Did not get fooled in the fact that the major hit drought was going to end. We said that last May, that the big storms were coming for the United States no matter what the ace did. Now, and that was the reason I didn't think it was going to be as big a year in total was because the multivariate ENSO index was in a pretty hefty El Nino stage and it just collapsed, right? Well, this year I think it's the opposite. It's tracking along 2006 right over here, and I think we're going to see it go the other way, and I have my reasons for that. Let me outline them. There's a lot of warm water laying underneath here in the Pacific. In addition, we're seeing the Southern Oscillation Index crash. What does that mean? That means the easterlies are weakening. And in the analog years I have, where I think a Modoki El Nino is going to develop late in the season on into next winter, hint, hint to next winter, and I'll show you that in a moment, we see the rapid drop-offs occurring at this time of the year. That's 2002, and there it is in 2006, and there it is in 2009. Actually, it's back over here. There was another second one as we got into the hurricane season, 2009. And then 2014, the most recent year, the downturn is occurring in here, as you can see. So it likes to do it in April and May, and it's doing it right now. So there, we have the warm water laying there. We have the Southern Oscillation Index changing. So there you can see we have the setup for what's going on. Precipitation patterns in the United States in March and April. Look at California, right? Look at Florida, and look at this area of wet weather in here and drier weather out here, right? The means in those years that I pointed out, wet in California, wet here, drier back in here. Look at Florida. And then what happened, though, in May and June of those same analog years? Florida got wet, was dry in Texas, right? See California drying out. Tends to be a lot of wet in the Northeast. Look what's going on the next couple of weeks. Lo and behold, it's going to that pattern. Now, this is a little bit different in here, but there's the dry in Texas, the wet over here. California's still a little bit wet in the air, but you see the similarities. So the weather now is giving us a hint of what the weather's going to do later. Nothing magical about it, nothing mystical about it, nothing man-made about it. Do you understand? I'm not doing any hocus pocus here. I'm showing you what's in front of us. Now, I know this is the hurricane update, but I want to show you. This kind of El Nino, I think, coming on, does not mean a wet winter in California. It's a Modoki, I think, is coming on. It's dry there. It's wet in here, but look what it does with the temperatures. And 3 out of 4 of those winters were very snowy. The other one, 0607, where we're tracking now, wasn't as snowy, but we had the coldest February on record right in here. So, see this, it's May, let's say May 12th, and I'm displaying a forecast for what may happen down the road here for you. See how I try to help out here? I'm always thinking of you. All right, so this is the current sea surface temperatures a week ago when I drew up the forecast in the Atlantic. There's the cool here, the warm here. That's directly opposite of last year. We're seeing computer models for the hurricane season, seeing the warming coming here, the cooling in here. All right, so that's starting to take place. Now, what's interesting is the pressure forecast. This and this relationship here means that the main development region of the Atlantic should not have as much activity as last year, right? And you see when you have higher pressures here, lower pressures here, you're slowing down the easterlies. And what that generally means is that the El Nino is coming on. But this is very interesting right here. What this says to me is, well, you don't worry about the long track storms that much this year, but in close development, it's going to be a pain. And when you have high pressure located over this part of Canada and on into the Northwest Atlantic, you have to be concerned about things just flaring up in close and then hitting the United States. So it's a very interesting look. Last year, in high pressure arced across the north, there's the high pressure in the Pacific. There's the lower pressures out in Australia, right? Opposite of what the forecast is this year, right? So we had the big ACE season last year. See where that center of low pressure is, and see the high pressure here, right? The analog years and the years, these are the years that we do not get big hits in the United States. You see the low pressure there in the Eastern Pacific, and you see the center of the low pressure is further north. In other words, is higher, even though these pressures are low, they're not as low relative to averages here. What does that do? That ruins the convergence. Remember, you're talking about, when you're talking over tropical waters, air that moves up very, very quickly. And if there's lower pressure to the north, it disrupts the normal processes that you would be looking for storms to intensify as they come toward the United States. So that higher pressure in here by the European forecast, a higher pressure here means, okay, we're probably not going to see the activity we had, the ACE activity, but the higher pressure up to the north has me bothered, all right, about impact this year. And again, there's that picture I was showing you. So what do we come up with? We come up with a total amount of storms of 9 to 13, 5 to 7 hurricanes, 1 to 3 of them major. The problem is where the strongest storms are going to occur relative to averages and relative to the total ACE index. So our ACE index started at 90 to 110, which was normal. So we're now a little bit below normal, but we may have these kind of storms that deepen in close to the coast this year because of the pressure patterns that set up. Let me see what this last one is. Oh, yes. This is what I'm worried about. Monday, Wednesday period, that low pressure develops here, feeds back, starts acquiring subtropical characteristics, and impacts this area. Already a lot of rain going on in Florida in front of it, but right now it's a cold trough. However, water temperatures are marginal, so we'll see what happens Monday, Tuesday, and Wednesday, and then the following week we got to look down in the Caribbean because we're going into that phase 2 of the Madden-Julian oscillation, and so phase 2 at this time of the year over warm waters can cause problems. Let me see if I could get that. Let's see if I have the latest MJO forecast. Yes, I do. It just came in. Okay, so actually it came in a little while ago. I just put it up here now. So let me see if I could show this to you. So that you understand, I always do this. I always wind up late, or there's always something I want to put up that I didn't see before that I put up at the end. Okay, here we are. So the Madden-Julian oscillation is forecast into that phase 2 over here, which is favorable for in-close tropical activity across our tropical in-close waters of the United States, and so that's why I'm concerned. So it's not magic, and it's not, as I said before, it's not magical, it's not mystical, it's not man-made. It's what nature does, and nature will do what nature does. Okay, does that make sense? Sometimes it does. Enjoy the weather. It's the only weather you got.